right, you should be able to hear me at this point, hopefully. All right. So thank you so much for being here, and welcome to OCX. It's weird because last time, at the same time of the year at our previous conference, I was literally having one of the last few sessions, and this year I'm opening this brand new type of conference for us. So anyway, thank you for being here. So if you don't know me, I'm Frédéric. I manage embedded and IoT programs at the Eclipse Foundation. I've been around for a while and did, well, many different things. Feel free to connect with me. And I published a book. It's nearly 2 years old at this point, so maybe it's not good anymore. Who knows? And there's nothing about ThreadX in there, of course, since at the time ThreadX was not part of our ecosystem. But anyway, if you're curious about what we've got in the embedded and IoT toolkit at the Eclipse Foundation, this is still a semi-relevant book, I suppose. All right, so let's start this morning with a question, and hopefully you will get the answer right. So Eclipse has many projects, over 425 at this point. Which one would be the most widely used in the world of those projects? And some of you maybe will, tell me that, oh, well, of course, this is big and enterprisey, so that would be Jakarta EE. A few millions of app servers all over the world. That's massive usage right there. Okay, yeah, good, but not good enough. I mean, of course, Eclipse IDE has many more users because typically you have more developers than you have app servers. Well, in most organizations, I guess. But even there, that's not enough. With Eclipse Temuran, we've got, lots of downloads every month. I think close to 60 million. So at this point, that's a few billion downloads or a few billion words of users all over the world. And of course, in a previous incarnation, we had some companies telling us, yes, there were billions of devices running Java. So, of course, all of that is true. But really, the true answer there is Eclipse ThreadX. Okay, ThreadX is the first open source real-time operating system certified for safety critical applications, but it's also the most widely used Eclipse project that you can think about. And you will tell me, how's this possible? I mean, never heard about it. Or it's so new, right? Microsoft gave that in November of 2023 to the Eclipse Foundation. How come it is the most widely used Eclipse project in the world? Well, that's the thing. There are currently in the world 12 billion devices running ThreadX, and this is a conservative estimate. Okay, of course, we don't have a very precise count, but if you have dishwashers from some very well-known German brands, they are running ThreadX. Maybe older versions, but they are running it. If you think about printers from some of the major makers in the world, they are running ThreadX. Once again, not necessarily the latest version, but this is embedded, so it's not a problem that it's not the latest version. So really, we've got this project with massive adoption, and yet it's brand new to the Eclipse ecosystem, and hence the talk, or the title of my talk, right? In the sense that Eclipse ThreadX is, a real star in terms of adoption, but it's been reborn at the Eclipse Foundation, and my goal today in this talk is really to give you an overview of what is provided with ThreadX, what it can do for you, and at the same time, let you see a bit about the possibilities it's got in the broader Eclipse ecosystem. So how do we come with adoption numbers like that, right? We say 12 billion devices, and of course ThreadX is an embedded piece of technology. Just in this picture, there's a bunch of potential ThreadXs all over the place that show how much potential there is for future adoption for ThreadX. It's 12 billion and counting, and we feel at the Eclipse Foundation that it has the potential to become much more prevalent in many different spaces. So of course, you will use it in appliances. ThreadX is certified for use in home appliances. It's got a bunch of certifications for that. So I told you about dishwashers, but it can be fridges, it can be anything you have in your homes. Of course, the stove, the freezer, the water meter from your town, maybe checking for water consumption, the dishwasher. And of course, in many of those devices, like my smartphone, okay, there's a bunch of other operating systems than the main one that I'm using as a phone user. right? There are plenty of subsystems with their own embedded firmware, and many of those would be able to run ThreadX. So of course, the camera system, right? You don't send to iOS or Android all of the information about the images. The sensor will do some pre-processing on camera. That's embedded firmware. That's potentially ThreadX. Of course, the battery controller is another example where ThreadX will be able to run. And in fact, there are a number of laptops and devices on the market that are doing just that right now. The touchscreen has its own embedded firmware as well to detect the touches and all the gestures. And once again, you don't want to send that to the main operating system. You do some pre-processing so that it's more efficient. Of course, the processor in the phone itself has got some level of embedded firmware because, well, essentially you want to to measure or to manage specific aspects like power management in the chip. So you will have a small embedded microcontroller just for power management inside your processor that's not running the main operating system for this phone. And of course, there are plenty of those controllers. And in most chips, they are not even built on the same architecture as the main CPU for the phone. So for example, in iPhones, there are many embedded RISC-V microcontrollers checking for power and other aspects of the chip, okay? And of course, since we're talking about embedded, then you can have, those very small embedded applications that will use ThreadX like a hearing aid or pacemaker and all of that. So just in this picture, there are plenty of ThreadX instances running all over the place. That's how we come to this 12 billion count for ThreadX in the sense that it is a very versatile platform that can be used for all of those applications and many more. So if you're less familiar with the space, because, well, this is a very broad conference with a diverse audience, so I didn't expect everyone to be familiar with real-time operating systems. So when we say real-time, this is not about higher performance or anything like that. It's a type of operating system that essentially will manage processor resources and devices on very, very small devices. And typically, an RTOS will manage the processor cycles, the memory, the peripherals, the interrupts. And really, the whole point of this is to have a variety of parallel tasks happening in real time, which means essentially that we've got predictable latency for things to happen. And why is this important? Well, think about it in a car, for example. You've got a real-time operating system controlling the ABS brakes in your car, okay? So you want a guarantee that when the brakes or the ABS function in the brakes is activated, that it will, well, that's the thing. If you need to activate it, if the car detects that it needs to activate it, then you need this thing to happen in a very specific amount of time, otherwise you die, okay? And so real-time is about those applications that are deeply embedded in our lives and, of course, have impact on human lives, directly or indirectly. So the main characteristics of real-time operating system, of course, typically they are small and fast, and they have a dedicated purpose. You're writing a custom firmware for a Fitbit, for a phone, for a battery controller. So, of course, this is not about deploying applications on the top of that real-time OS. It's about writing a purpose-driven firmware. And really, once again, you have deterministic processing requirements. When I do a function call, I need it to return in always the same time in a very, very predictable fashion. And of course, the hardware target is a far cry from what you would see typically in the server space, in the sense that we are not talking about gigabytes or petabytes of memory or storage or that kind of stuff. This is really on a very, very, very small scale, like early days of computing, you would say. So typically less than 500 kilobytes of memory and less than 200 megahertz processor frequency. Of course, ThreadX and other real-time OSs can be deployed on more powerful hardware than that, but they can run on very, very small and very constrained environments. And even a memory management unit is not necessarily required. So once again, this shows how small and how cheap we can go in terms of hardware platforms. Because when you think about it, about this picture, I mean, given the number of small microcontrollers running ThreadX instances in that picture, you cannot afford them to cost 100 euros per instance. I mean, some of them maybe are more powerful, but most of them are very, very cheap, very, very targeted hardware platforms. All right, so now, what would developers want from their real-time operating system? The first thing is, of course, the ability to execute multiple threads. Because we are running on a very simple platform, a low power or affordable platform, doesn't mean that we want to run just one thread at a time. Okay, and typically you will have a single processor core to deal with to keep costs down. Although ThreadX supports SMP, so you can have multiple processors and distribute tasks and things like that over several cores or several subcomponents in a SoC. But really the sweet spot there is to ensure that you maximize utilization among several threads over a single core. And then, of course, the way that you execute those threads must be flexible. So you should have nice things like thread priority, and of course the capacity to suspend threads as needed. So for example, if you're dealing with a battery-operated device, then of course you will put some less priority some tasks on sleep and just awaken them periodically to transmit data, for example. So you would watch for certain conditions in the environment, and then when you receive a specific signal on a sensor, then you would awaken that thread and start transmitting data. Like in an alarm system, for example, if nothing is happening, you don't detect movement right now, you don't need to transmit anything back to the base. Of course, even though we are dealing with a very small set or very constrained hardware platforms, we need full capabilities. We need networking, we need USB, we need storage, because those applications need to deal typically with gathering data or sending data to the cloud or receiving commands from the cloud and that kind of stuff. So, of course, even though we are trying to fit in a very small and affordable platform, we need a full complement of capabilities in order to build applications on the top of that platform. And then it's all about how you manage development and you manage those applications, of course. So you want to, when the application is running, to be able to synchronize threads, and of course, you've got the basics like mutexes and semaphores, but you need higher level type of features to be productive as a developer as well, and ThreadX delivers on many of those. And finally, you need a full complement of supporting libraries or supporting modules, and a few key ones would be a TCP/IP stack, a file system, GUI framework to be able to have human interfaces, and of course USB support. Now ThreadX delivers all of that, and as I said, it's the most widely used Eclipse technology in the world, and the reason why it's got 12 billion devices in the field is that it's got a very long history. So ThreadX started in 1997, so it's older than Zephyr, older than FreeRTOS in terms of code maturity. At the time, it was a proprietary product by a company called Express Logic. And Express Logic developed ThreadX for a very long time, over 20 years, when finally they decided to accept an offer from Microsoft, and the whole company was acquired by Microsoft, and at the time, ThreadX was renamed as Azure RTOS. And the model for Azure RTOS was a bit unusual in the sense that the full source code was put on GitHub. But the conditions of use for the license were fairly restrictive. You could use it freely if you were building proof of concept, but if you were deploying anything to production, you had to buy a license from Microsoft, except if you were using hardware from Microsoft's partners, then you could have licenses built in the boards that you were buying from Microsoft hardware partners. It was quite complicated. I mean, if you think that Eclipse memberships are complicated, the licensing model for Azure RTOS was even more complicated. Can you imagine that? Anyway, Microsoft tried for a number of years to build an ecosystem around it, but really the goal there was to drive people to Azure Cloud. But people don't like to be painted in a corner and be told which cloud to use and which platform to use. So let's say that in terms of commercial success, well, it was successful, but not necessarily meeting expectations. And so Microsoft, after a number of years, decided to divest from the technology. And rather than killing the product, because they are not Google, decided to contribute it to the Eclipse Foundation, and this is how Eclipse ThreadX started back in November of last year. And the big difference there is the licensing model. So at Express Logic, it was a pure proprietary license. At Azure, as Azure RTOS, the model was on a number of devices. You need to buy a license or to have a pre-licensed board from a partner. In the case of ThreadX now, we are under the MIT license, so you can do whatever you want with the code, and you don't need to contribute back your changes. So that's quite a big difference, of course. So what's in the toolkit for ThreadX? ThreadX is the name for the kernel, and it comes in two distinct varieties: ThreadX for single-core systems, or ThreadX SMP for multi-core or multi-processor environments. Okay, but in this case, we're talking about a very small, small kernel, which is certified for a number of safety-critical applications. Then we've got FileX, an embedded FAT file system, and there is fault tolerance that you can configure on it if you like, if you need that. Not apparent on the diagram is something called LevelX, which means if you're using flash storage, one of the problems with flash storage is that depending on the type of file that you are using and that kind of stuff, it's probable that some areas of the storage chip will wear out faster than others, like the one folder where you have this big log file, for example. Well, in the case of FileX, it's got LevelX, and LevelX will spread the load across the chip so that it will be more durable in the terms of flash storage chips. So it's really interesting from that perspective, and this is not something you need to take explicitly advantage of as a developer. You know, FileX, if you configure it with LevelX inside, because it's optional, but if you configure it with LevelX, it will do the wear leveling for you in a transparent fashion. ThreadX has also USBX, fully featured USB stack, a full-blown TCP v4 and v6 networking stack. GUIX has both a set of widgets and a designer tool to implement or to design the user interfaces. And it's got also TraceX. So essentially, that's a companion tool where you can instrument your applications running on a board or on a simulation environment in real time. And I know that our friend Matthew from Ericsson also added support for TraceX format to Eclipse Trace Compass. So if you like Trace Compass, I'm not sure if that thing or that new feature has been merged or not, but in any case, ThreadX is also compatible with Trace Compass. And as I mentioned, we've got a number of safety certifications for ThreadX, and ThreadX is literally the only real-time OS which is both open source and safety certified. So they've been working on this at Zephyr for many years. But in our case, we've got those existing certifications, and you can purchase our safety manuals in order to certify your own applications. So we are certified for IEC 61508, so essentially any safety critical system in electrical or electromechanical environments is covered by that. Then you've got IEC 62304. And of course, EN 5128 for trains. So essentially, any type of vehicle you can think about for public transportation or private transportation, ThreadX is certified for that. And of course, you know, we have a number of UL certifications on the other side of the slide for use in home appliances. So dishwashers, washing machines, all of those nice things that we've got in our homes. And in the middle, that's not a certification per se, but of course, MISRA C rules are really important when you're dealing with embedded development. And in our case, we are compliant with all required and mandatory rules there. So it's a very clean, very compliant code base, and a very mature one going all the way back to the 90s. So let's have a closer look at the various pieces in the stack and what they provide to you. So first, ThreadX, our core scheduler, it's very small. You can make it as small as 2 kilobytes for deeply embedded applications, and yet it will provide you sub-millisecond context switches. So if you need very low latency and lots of reactivity, certainly ThreadX is for you. It has a very consistent API and really comes with a number of really interesting modules, especially modules with memory protection. So this enables you to ensure that some memory zones are not corrupted. So of course, going back to the 90s, ThreadX is written in pure C. So it's not as trendy as Rust or anything like that, but with memory protection for modules and other features and MISRA compliance. Let's say that you don't necessarily get what you get for free with Rust, but at the same time, with proper development practices, you can ensure that you won't have any memory buffer overflows or any nasty bugs like that. Then comes NetX Duo, so the network stack. It's really small when you consider everything that's included, as small as 50 kilobytes. And really there, one of the nice things that it's got, most of the features in there rely on zero copy for lowering memory usage. And the parts that are in gray in the diagram are the parts that are safety certified. As you know, safety certification is very expensive. Certifying the whole set of protocols in there would probably be overkill because, well, if you look at what's included, we've got a email client for POP3, so maybe you don't need to safety certify that, right? But at the same time, the core in terms of TCP and TLS, IPv4, IPv6, and the MQTT client is safety certified, which means this is suitable for a wide range of really serious use cases, and especially in automotive, once again, where you find more and more MQTT being leveraged in software-defined vehicles. The feature set there is extensive, I should say, and it's very modular. So whatever feature you don't use won't add to the total size in memory at runtime. So it's really meant to minimize the bandwidth consumption and to minimize the CPU usage as well, since of course anything related to encryption can consume lots of CPU cycles because of the handshakes and all of that. So from that perspective, it's been really deeply optimized, and it's a really well done networking stack. ThreadX is as small as 9K. Very broad support for a variety of physical storage devices. And of course, for flash storage specifically, you've got Level X mentioned at the bottom. But it will work with SD card, it will run with RAM disks. Really, this is a general purpose implementation of the FAT subsystem. ThreadX was previously safety certified. The problem is that it was providing an exFAT implementation as well. And Microsoft still have a patent on that particular technology, and they provided the implementation, but didn't give a license to the patent, so we had to remove the code, unfortunately. But it still supports FAT 12, 16, and 32, so you can still have fairly sizable storage devices with that. And well, hopefully when the patent expires in a few years, I think it's in 2027, if I'm not mistaken, or something like that, then we can restore support for exFAT in there. USBX offers support for both host application and device application, which means you can plug USB devices on ThreadX-powered devices, and of course you can develop pluggable devices with ThreadX as well. And you see various USB device categories listed in there. Some of them, like audio and printer, are straightforward, and the others are more specialized. But in any case, whatever you can dream of in terms of USB support is supported by USB-X. It will leverage direct memory access, and of course, the nice thing is that it's decoupled from any specific USB controller implementation, so you can support a very broad array of controllers according to whatever use case you are. GUIX. GUIX is a very small set of user interface widgets. And it's also, we've got something called GUIX Studio, which is the design tool for that. Unfortunately, GUIX Studio is Windows only for the time being, so we're looking for volunteers trying to port that to, I don't know, Eclipse ThreadX or Eclipse IDE or something else maybe. Anyway, but it's still a very good tool you can deploy on your laptop to generate, you know, the code for the user interfaces for you for integration in your ThreadX application. And really, the widget library is fairly comprehensive. So those are examples that you see on my slide of the type of user interfaces you can build with ThreadX. It doesn't have very, very deep, well, you don't even need a GPU in your environment to be able to support this. Of course, this will, you know, if you're using a very small, low-power microcontroller over battery power, I mean, those nice user interfaces could drain your battery fast. But anyway, there are no requirements for a GPU. And you see on the left side of the slide a screenshot of the GUIX Studio. So it's a very nice environment. You drag and drop the widgets. You build your user interface. It will generate the C code for the runtime part of the stuff for you. So it's a very nice tool, although, as I said, for the time being, Windows only. One thing that's really nice about ThreadX is that it's been tested in terms of performance recently in this very recent report. So if you look, if you Google for Benigo Embedded Group 2024 RTOS performance report, you will find the report. You can download that for free. And essentially, ThreadX came on top of all open source real-time operation systems by a large margin. So it was really in order Zephyr as the slowest, FreeRTOS, and then on the top by a very, I think it was over 33% faster than FreeRTOS, if I remember well. That's quite a good margin. Of course, there were some proprietary options in there that were even faster than ThreadX. But then when you consider the licensing cost, I think we've got a very good price-performance ratio in ThreadX. So I invite you to have a look at the report. It's really well done. And the testing suite is open source, so you can download the code for the tests that they used and run that in your own environment if you are so inclined. So why would you pick Eclipse ThreadX for your project? Really, there's a bunch of arguments for it there. Of course, if you need deterministic latency and true hard real-time requirements, then ThreadX is for you. You know, now with preempt-empty part of the Linux kernel, some will argue that embedded Linux can do everything for you, but if you talk to true real-time people, they will tell you that preempt-empty is not actual hard real-time. So anyway, we could have that debate maybe another time, but one thing is sure, there's still a place in the market for dedicated real-time operating systems. ThreadX is high code efficiency, very small footprint, extensible as you've seen, and of course you can bring up your own custom modules on the top of everything I presented. It really has a high reliability and really with the safety certifications that we've got really can cut down your time to market and risk in developing safety certified applications. Of course, there's a rich toolkit. It's under MIT, so you do whatever you want with it without any trouble in terms of licensing. And of course, we have a number of semiconductor and software partners that work with us to ensure broad hardware platform support. So if you're intrigued, all you need really is a laptop or desktop and a C compiler. And then you install CMake and Ninja, and that's it. That's all you need, no complicated SDK there to get started. So once again, from a developer setup standpoint, it's quite straightforward. Of course, it's not tied to any specific IDE, although Microchip, Renesas, STMicro, all have development tools that supported as you are us, and at some point will support ThreadX as well. And the other thing in terms of the software bill of materials is that ThreadX has literally no external dependencies. So everything I showed you, including the crypto, the network stack, all of that is in-house, so to speak. So you don't have any other dependency to think about. And in terms of hardware support, this is intentional, this is hard to read. Just to impress on you, we have plenty of it, right? Including some RISC-V based chips. And now we are starting to work with Open Hardware Group to ensure that their Core 5 line of open source microcontrollers and cores support ThreadX properly as well. So this will be an exciting all open source adventure coming up in the upcoming months and years. So, if you are interested in supporting ThreadX or if you want to license the safety manuals, the place to go is what we announced just 2 weeks ago at this point. It's, it's fairly recent, the ThreadX Alliance. So this is a new model where essentially we didn't want to constrain the reach of ThreadX to just the core cast of Eclipse members. So the ThreadX Alliance enables non-Eclipse members to contribute to the ThreadX ecosystem and to purchase the safety manuals. Since those are commercial transactions, we couldn't do that straight in our non-profit context at the Eclipse Foundation. So this is why we set up this distinct organization, so to speak. But in any case, the ThreadX open source project, ThreadX Alliance, and all of that, of course, is still working hand in hand with the Eclipse Foundation. So, my call to action to you. ThreadX is a mature real-time OS, but as a newborn Eclipse project, it needs your help. Of course, you know, please get the code and use it. We need more adopters, we need more users, and as you've seen, it's fairly straightforward to get involved, so please feel free to jump in. Please stay informed. So we have a general ThreadX mailing list where you will get most of the announcements, and there's a bunch of other mailing lists. There's the developer one, there's the one for user questions, we've got channels on the Eclipse chat service. Anyway, so plenty of other things, but if there's only one channel you want to follow, it's probably the main mailing list. Please join the ThreadX Alliance if you want to support the only real-time operating system which is safety certified. We need your support because safety certifications are great, but they are very expensive. So the ThreadX Alliance enables us to pay for that. And when I say that, it's literally auditor fees from very expensive, grumbly German companies that will check in detail the development process and all of that to give us our safety certificates. And then we need contributors, we need committers. So, of course, this is under MIT license. Anyone and everyone can contribute. The bar will be a bit higher for contributions because, of course, we need to ensure that everything is still correct when the changes touch the safety certified part of the code. But anyway, you know, we need you. So thank you so much. And if you're curious and you like ST platforms, this is a recent book by an author in our ecosystem. Sean is really an awesome author. Plenty of good tutorials and code samples in there. So please have a look at this book. It's very recent. And if you're curious about trying out ThreadX, I will be at the upcoming SDV Hackathon in Karlsruhe in November. So as a hack coach, to be there to guide you in our ThreadX and Beyond challenge. So, thank you very much. And I guess we are a bit over time there, but maybe a time for a quick question. So, any questions? Oh, gosh.
Thanks for the talk, Fred.
Of course.
I was wondering if the fees that are required to purchase the safety manuals, does that apply for everybody or just for non-Eclipse members?
So the way this works, the ThreadX Alliance, you have to pay a fee to be a member, and then there's a licensing fee for the safety manuals. What we waive for Eclipse members is the ThreadX Alliance fee, but you still need to pay the fee for the safety manual, and the reason for that is really that those certifications are very, very expensive, and we needed a distinct, a dedicated revenue stream just for that.
Got it. Thank you.
Of course. I think you had a question, sir? And I guess that will be the last one, right? Yeah. Okay.
My question is related to how you manage the safety certification and the contribution. Who is testing the process? Because it's interesting because I think it's the first project, or let's say, open source project that accept external contribution but safety certified.
Yes, and the answer there is, I would say that an ongoing story in the sense that at this point in time, not everything is fully into place for that, right? So the currently certified version of ThreadX is version 6.1 that had been certified by Microsoft back in 2021, I think, around. And we will certify the next release, the last release of ThreadX, Eclipse ThreadX version 6.4. But that one had been built by the previous Microsoft-owned process as well. So we don't have as many new elements to take into account. So that's our immediate next step. However, for the next release, 6.5 or 7, whatever it will be, we will be relying on what we call the Eclipse safety process. So you know at Eclipse, we have the Eclipse development process, which is used by all of our open source projects. We also have the Eclipse specification process for specification projects. And now we are coming with what we call the Eclipse safety process that will be used by all Eclipse projects that aim to be safety certified. So we have a process engineer on staff working on fleshing out that with the Eclipse management organization team. And of course, the Eclipse ThreadX project is the early adopter of that process. So we are, and I made at Embedded World North America 2 weeks ago a presentation on just that, how our safety process is shaping up. So we should connect and I can share my deck with you to give you a taste of where we are at it. But we are literally building this right now. So details may change a bit, but the general principles have been established. And of course, maybe my presentation to this conference, the next time we meet, will be about in detail reviewing the process and how it applies to the Eclipse ThreadX project. So thank you so much for your question. So we are out of time. Thank you for being here today. I hope it was useful. And of course, I will be at the Industry Collaborations booth right after this talk. So if you want to talk about everything ThreadX or anything about IoT and embedded at Eclipse, I'll be there for that. So thank you.